Hey trick class, let's look at this ambiguous case of the law of sines, which means again we have a triangle that could potentially produce no triangle, one or two triangles. So let's label this angle A right here. That means this is little a, and then we'll call this angle B and this little b, making this angle C and this little c. So angle A is 70 degrees, and what's opposite that is little a, which is 8 units. Right, and then B, this side over here, is 7 units. So the first thing we want to compare is the opposite side of the angle that we're given, which is this 8, larger than the other side length that we're given? And you can see it is. Side A, which is opposite the angle, is greater than side B, which implies one triangle is possible. So we're going to select a single triangle as possible, and then we have to solve the triangle basically then. Alright, so the first thing I want to do is come up with this angle B right here. Okay, I've got a side and its opposite pair, so I can do the same thing with the law of sines for the angle B. So because I'm solving for an angle, I'm going to set the sine of angle B over the side length B, and that is equal to the sine of the 70 degree angle over the side opposite it, which is 8. Alright, doing a little arithmetic, I can get sine, I guess algebra technically, of 7/8. I'm just multiplying the 7 over, putting it over this 8, times the sine of 70. Right, and then B is the inverse sine of all that. Right, second sine is inverse sine. 7/8 sine of 70. Again, you want to make sure you are in degree mode when you're doing degrees like this. So there's 55.31 degrees. Right, everything it says 2 decimal places, so 55.31. Alright, now I know 70 and 55.31, I can use the 180 rule to get C. So it's approximately 54.69 degrees. Alright, now I have every angle. All I need to do is find the side opposite this 54.69 degree angle. So that's again the law of sines, but I switch and put the side lengths in the numerator when I'm solving for a side length. Okay, this was the original pairing that was an opposite angle and its opposite side length that I was given, so I will use those. So side length on the top, that means 8's on the top, sine of 70 on the bottom. All right, multiplying the sine of 54.69 over, I get C is equal to that exactly, and then I can round that to 2 places. All right, so hit enter. There's our approximation, 6.95 to 2 places, and so there are my 3 side lengths and 3 side lengths, 3 angles. So B was 55.31, C was about 54.69, and little c that we just found was 6.95. Alright, let's do a quick little check that you can do. The largest side length should be across the largest angle. The smallest side length, 6.95, should be across from the smallest angle. These are almost the same angle, just slightly different, and you can see that that's 6.95 and 7. This one is just slightly bigger than this one.